The goal for this exercise is to get the user started on building an awareness of the unit circle. And I have found that building it on this software helps to do that. So we're going to play around with GeoGebra. The first thing you need to do is just open a file, and we'll go ahead and save that file. So from a student perspective, just remembering all of this information can be really difficult. Now, we'd like our students to kind of study and spend a lot of time kind of working their way around the unit circle so that they really build knowledge of it, but what we tend to get is just a memorization of the points without any real understanding. So I'm proposing that this activity doesn't take any longer than just studying their tables of the unit circle, and might actually help to develop an awareness of what's happening around the unit circle in such a way that their knowledge will be built more on understanding than simply on memory, so they can use it from course to course. So we're going to start with the circle tool, and we'll build a circle through a point, and let's have that center of that circle be at the origin, and I just want to make a circle that'll fit inside the screen I'm working in. So this point B is arbitrary. It's simply the point where the circle kind of stops being in my view. I would like to build the X and Y axis with a line attached to the X and Y axis. So I'm going to put my line through the origin, and then I'm going to place another point on that line that's on the X axis. So I wait until this pop-up box appears. It tells me that I'm on the X axis. So this line, no matter how I drag the points around, can't be off the x-axis, and that's what I'm looking for, because I'd like this perpendicular connection in the middle. So let's use the perpendicular line tool through the origin, perpendicular to the line I've created on the x-axis, and now we have a line that lives on the y-axis, and we can check that by looking at what we've built here. I've got a line where y equals 0 and a line where x equals 0. I can take a look at the points to see kind of what I'm working with as I move around. At this point, oops, didn't need that D, I'm going to hit the back arrow. Maybe it'll take care of just my D, and maybe it'll take more off than I want. So sometimes you have to hit the back arrow followed by the forward arrow to put things back on. Now this C is a label for this equation. I'm going to turn that label off simply by right-clicking on the equation called C, go down to Show Label, and turn it off. I don't really need B, although turning it off may turn the circle off. Nope, I don't need C, so I can actually delete C. What happens if I delete B? The circle goes away. Okay, so back arrow puts the circle back. So it works just like a Word document. If you make a mistake, just undo it. And at this point, since I'm on the circle and I'm on the y-axis, I'm adding a point here so that I can overlay a radius. So give me the segment tool. From A to C, I'm going to turn the label off for C. From A to C, I would like this to be a radius equal to R for the unit circle. So I really want to be able to turn the axes off. I don't need my segment labels, so show label, show label. And let's right click on the white background and go ahead and turn the axes off. So at this point, we have a unit circle. Let's go ahead and edit this text to include a statement where our radius equals 1 unit. So at this point, perhaps the user knows that the unit circle is named for that radius equal to 1, and perhaps they don't. This would be a good time to build at least that awareness. Don't need a label on D. I think I'd like a label for now on A, but I'd like it to be the label O. Maybe I could even turn off the label but show the caption and have that caption say origin. Let's see. Yep. Again, I mean, at some point our students learn the word origin stands for the point at 0, 0, but we don't know when that point is, and maybe they haven't had that point yet. We need to make some marks. So the unit circle is constructed on a circle with radius equal to 1 with several important points. So we're going to choose the angle with a given size tool. We'll then select a leg, then a vertex, and we'll enter the size. We're going to experiment with what direction it goes in. At this point we need to go in both directions, so I'm going to select a leg. I didn't select a point, so I'm not sure why that's ready to start. Select a leg. Well, we'll find out. 45 degrees, and let's start by moving it to quadrant 1, so that is counterclockwise. Well, somehow it just knows that this is my point, so this will work actually pretty well. And it's even landing on the circle. That's even better. So let's try again. We could use a 30 counterclockwise. That's helpful. There's my 30. Now, I'm thinking that it would be interesting if we could do this. We can. So I've just made a 60 by saying 2 times 30. So can we keep doing that? Because wouldn't that be an interesting way to build an awareness of how the unit circle is built? Our students aren't necessarily aware that this simply keeps repeating. So let's now go to 4 times 30. And let's go to 5 times 30. I think this is a great way to build an understanding of the angles expected, the points expected, the understandings expected on the unit circle. 6 times 30. 7 times 30. 8 times 30. 9 times 30. And at this point, maybe they start kind of owning the idea that that's where the 270 lands. 10 times 30, 300. 11 times 30, 330, and then I'm back to 360. I already have a section for that, but let's go ahead and put it on there just for the fun of it. We can turn off anything that seems redundant. I'm not sure where that one went. Angle from here. 12 times 30 counterclockwise. I expected it to kind of close this, but not that concerned about it. Now I only have one of my 45s in here, so let's put the rest in. 2 times 45 is going to land me right on my 90, or 3 times 30, so I already have that one. Let's go ahead and go to 3 times 45, which landed me a new point here. 4 times 35, 45 that is. 5 times 45 with the angle tool. We already have a point for 6 times 45, that lands here. We just need one more for 7 times 45. Segments for each of these. I'm going to go to options. I really would like to turn off the labeling. I'm going to turn the label off for D, and let's see if we can build segments without labels that we later have to turn off. And we can. That's great. So we have a lot of stuff attached to the origin. And we're just going to click around until we have segments in each of these places. And it's really the coordinates of each of these points that we'd like our students to recognize, and the measure of these angles that we'd like our students to recognize. And I think that this exercise, having them actually construct the unit circle, is a really good way to help them develop that understanding. I'm going to turn B back on because I think it's the point that moves my circle. I want to make sure that everything stayed attached, and it did, so I can play around with this angle a little bit, or this circle a little bit. Turn B back off for now. I'd like to clean up that mess I have in the center. So where are all my angles? Now that I have segments constructed, I don't really need the angle guides. So I can just go through and click on the radio button and turn them all off. They'll still be there kind of in your menu if you want to go back to them. We still have our label for origin. It could turn out that that is more than we want to have. But for now, it's not getting in the way too much. Now, if we really wanted to build an awareness of the triangles in standard position, then we can drop that altitude using the perpendicular line tool. So perpendicular to the horizontal axis is one way to do that. Or we can simply create segments from my 230 and negative 30, my 45 and negative 45, my 60 and negative 60, all the way around the unit circle. So we're connecting the segments for each of the angles with its opposite. Using the move tool allows you to move this label around. I feel like it's going to eventually be in the way, but for now, this is a start. So let's go ahead and play around with what we can do with the labels here at each point. So I'm going to right click on the point at 30, go to Object Properties, and here's where we can play with the caption. It'd be kind of nice if I could do pi/6 notation here, and I think that I can. So show object, show label, and choose caption. Yeah, there we go. So this point right here tells us that the angle in standard position here is at pi/6, and it is 1, 2, 3, 4, 5, 1/6 of the semicircle that is represented by pi. So let's go ahead and get pi's label in there. I'm not on the point I need to be on. Sometimes if you're not able to select the point you'd like, it is because 2 points are highlighted over here in the algebra menu. So I'm clicking away from both points, and I'm going to select this guy. I shouldn't have turned it off, so I'm going to turn it back on. By clicking over here, there are 2 points on that space. I really only need one of them. And I'm going to make the caption pi. And I'm going to show the label as just caption. And there's pi. Oh, let's go to pi/2 next. Now see, there's quite a few points, so I'm going over to choose just one of them. Right click, pi/2. Show label, caption. Now there's a lot of steps to forget here, so your students will have the opportunity to repeat things, which is kind of the great news as they work around. But it's the working around that develops the awareness that allows them to learn the unit circle, not simply memorize the unit circle. Pi/4, I think I was on 45, and there's my quarter pi. How many sixths of pi am I at? Well, if I count from no sixths to 1/6 to 2/6, here's my pi/3. So even in just the exercise of forgetting to turn the caption on, will create in your students kind of this slow thought time where they have to spend time with these points, kind of really developing an awareness of them. So pi/4, here's a couple of pi's/4, which gives us our pi/2. Here's 3 pi's/4. The move tool allows you to give those a nice space. And I will finish these labels up at the end of this video if this software allows me that time. But let's move on to some of the other things you could ask for, or some of the other ways you can use this tool GeoGebra to highlight certain things on this circle. So what would be the best triangle to start with? Well, we've got this pi over 6 triangle, which makes this angle pi over 6 with a radius of 1. Could we work our way around to this height here? Well, yeah, there's 1/2, and this distance here along the x-axis, there's my 1/2 pi over 3. So we're also developing a sense of the 30, 60, 90 triangle here. I'd like to turn this point off for a second. And I would like to see that 90-degree mark. So I'd like to clearly show that this is an angle in standard position. So I use the angle, hover over the tool to see the directions for how to use it. Select 3 points or 2 lines. The points should be in clockwise order. So I chose point, followed by point, followed by point. If your angle is 90 degrees, you will get the square mark, as opposed to just the rounded angle mark that we saw when we did the angles at the origin. I don't really need that label, so I'm going to get rid of that. So I think I'd like to mark this coordinate as well here. So my y height is 1/2, my x height is radical 3 over 2. Let's see how we can best give this a coordinate. So let's go to properties, name and value. Let's see how much we can do with this name, or maybe we just add to the caption. What will it let me put in this caption? Do I have a square root symbol? Well, that's not ideal, but it's not terrible. I don't know, is this any better? Square root 3 over 2, comma 1/2. Not completely terrible. So you can play around with how you want the coordinates to read. I'm just going to work my way around these, finishing these labels, and we'll go from there. So it is kind of concentrating on the software that turns this into a fast thought. It takes this from a fast thought task, like memorization would be, to a slow thought task where they have to hold these ideas in their mind. So now I'm at 8 pi over 6, which I need to reduce. There's my 4 pi over 3. Students can be doing this on paper. Nothing stops them from working these out on paper, or they can be practicing how to hold these ideas in their head as they work around. But moving this into a slow thought process is really the value of this exercise. And that is my 45. So I have named this point incorrectly. I'm going to make this my 4 pi over 3. Errors like that, good to analyze, good kind of error for a student to make. Having to correct that kind of error is a good exercise. So everything about learning to use this software and having it take longer is good for students to work through. So there's my, so a student might now go back to, wait, there's my pi over 4, there's my 2 pi over 4, there's my 3 pi over 4, 4 pi over 4, 5 pi over 4, 5 pi over 4, is what I really want here. And while I'm at it, you know, it may make sense to me to go over here for 6 pi over 4 or 3 pi over 2. And this is the kind of activity that I might give as a performance example. So I might give students time in class to do this, kind of on their own, independent thought. I might give teams the opportunity to work on one of these, although it is more difficult. Although you could use a hot potato where one student adds something to the unit circle, explains what they're doing to the group, and another student adds the next item to the unit circle and explains what they're doing to the group. So from that perspective, it's probably a great way to spend an hour together on a team. Or you might give this over a course of a few days. In about an hour, a student should be able to get most of the structure labeled in their first try, even if they have no experience of this software, because they could absolutely be doing it with a video playing on the background. But a couple of days, given a couple of hours, this is the kind of activity a student could be working on over the course of a week. Let's say you ask for labels in quadrant 1 today, add labels in quadrant 2 tomorrow, add the labels in quadrant 3, then the labels in quadrant 4 after you've built the structure in class together. There's an unlimited number of ways you could use this kind of exercise in a class with students. Here's my 3 pi over 2. So as I was thinking about this, I put my 3 pi over 2 in the wrong place. So that was 6 pi over 4. This is really 7 pi over 4. So this is the kind of error you want students to make. It's the kind of error you want students to correct. It's even the kind of error you want students to see you make and to correct you. An analysis of the kind of errors students make themselves is a good analysis. These are good awarenesses to have, especially when moving into higher stakes examinations. If you know what kind of errors you're expected to make and you know what kind of analysis it takes to correct them. So here's my 8 pi over 4 or 2 pi. If you know what kind of errors you might make, you as a learner might make, then that's a good sense to have. I'm going to click on some white space because I have more than one point selected, to go to properties so that I can get this basic tool. Here's my 2π. Label, caption. So certainly to start, we want students to have an understanding of the radian measure of the angle in each position. And as we build awareness of the unit circle, we also want them to be able to give a coordinate of any particular point, so that you could eventually, and fairly quickly I think at the start of a course, hand out the blank unit circle and ask for labels. So this can also be used as a remediation tool. You've tried something, you have a certain percentage of students who have developed at least a memorable understanding of the unit circle, or at least a memorization of the unit circle, but you've got students who didn't score well on the first assessment of the angles and their coordinates. So this kind of exercise might be used for remediation. I'm looking for point D prime sub 11. And what was that? So your student might be going, okay, so back to pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. 1, 2, 3, 4, that is 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 9 pi over 6, 3 pi over 2. I need to change my label on this point. White space. Object properties. Hello, 3 pi over 2. You thought you had me fooled. And so 9 pi over 6. 10 pi over 6. So here's my 5 pi over 3. 11 pi over 6. 12 pi over 6. So we are counting these in different ways with different units. Is this my 11 pi over 6? I think so. And each of those units should have the same kind of reconciliation. And students will make errors along the way. Being able to analyze their own is kind of one of the goals. 11 pi over 6. 10 pi over 6, that's 5 pi over 3. And there's a feeling of accomplishment when taking a look at an item like this. And there's lots of work you can do with this file. Reflect a triangle over the vertical axis to show that there's a rigid transformation called reflection that tells you that each of the angles from this polygon must be congruent to each of the angles from this polygon. Reflecting these around again, reflecting, rotating, any number of geometric observations about the unit circle can be displayed here. So this is a really good tool to start building an awareness of the unit circle, or the circle where radius equals 1 unit. So play around with it and see how you like it.